All right, so here we're minimizing that C subject to those two constraints. So first things first, let's make our A and our A transpose. So A is going to be what? Well, it's going to be a 1, a 1, a 3, and a 6, and then a 2, a 1, a 1, and a 9, and then a 14, an 8, a 20, and a 1. So that's going to be our first matrix. Then we're going to take the A transpose. And so that first row becomes 1, 1, 3, 6, then 2, 1, 1, 9, then 14, 8, 21. And so now we have that. And so this was x1, x2, x3, and now this is y1, y2. Okay. So notice we went from two equations. Now we have three plus our maximization problem. So we're going to take this and go to our dual problem. And so if we write that out, we'll have what? Y1 plus 2y2. Now it's going to be less than or equal to, and that's going to be 14. And then we'll have y1 plus y2 less than or equal to 8. And 3y1 plus y2 less than or equal to 20. And if we write our new problem, it's going to be a max P equals what? 6y1 plus 9y2, and y1 and y2 have to be greater than or equal to 0. Now we're going to convert to the E system, and we're going to add in our x's. And so that gives us now, it looks like y1 plus 2y2 plus x1 equals 14. Then we have y1 plus y2 plus x2 equals 8. And 3y1 plus y2 plus x3 equals 20. And then take the other stuff to the other side. So minus 6y1 minus 9y2 plus p equals 0. And y1, y2, x1, x2, x3 all greater than or equal to 0. Okay. So now what we need to do is we need to write this part into our first initial simplex tableau. Okay. So our x's are going to go on the outside. So we'll have, where's my right? There it is. X1, X2, X3, P. And up here we'll have Y1, Y2, X1, X2, X3, and P. And then we'll put a line, and we can put our dotted line here. And so writing that across, we had 1, 2, 1, 0, 0, 0, and then it was 14. Then we had 1, 1, 0, 1, 0, 0, 8. Then we had 3, 1, 0, 0, 1, 0, and then 20. Then we had a minus 6, a minus 9, then 0, 0, 0, 1, and 0. Now, we're going to find our quotient, but first we have to figure out which one's the largest negative. Well, that looks to be our largest negative. So we're going to take what? 14 divided by 2, which is 7. We have 8 divided by 1, which is 8. And we have 20 divided by 1, which is 20. So that's our smallest. So that's going to be our pivot point. So we're going to enter here, and we're going to have exit here. All right, so that gives us y2, x2, x3, and then a p. And then we have this over here, something like that. And so what we're going to have to do is we have to do a 1/2 row 1 is going to be our new row 1. And then if we take minus 1/2 row 1 plus row 2, that's going to be our new row 2, minus 1/2 row 1 plus row 3, that's also going to give us now our row 3. And now this one's a little more complicated, so now we're going to have to take 9/2 row 1 plus row 3, 1, 2, 3, 4, rather. And that's going to be our new row 4. Okay. All right. So first things first, half of that first row. So that's a half, a 1, a half, a 0, a 0, a 0, and a 7. And we're going to take a minus this plus that. So that's going to be 1/2. That's going to give us 0. It's going to be a minus 1/2. It's going to be a 1 and 0 and 0 and a 1. Minus again, so that's going to be what, 5/2. And then it's going to be 0 minus 1/2 and then 0 and then 1 and then 0 and that is going to give us 13. And then we're going to take 9/2 times that first row, and then that's going to give us what, a minus 3/2. That better be a 0 there. That's going to be a 9/2, and then 0 0 1, and then that's going to give us what, 63. All right, so smallest one is going to be that one. That's the most negative. And so now our quotient is going to be what? 7 divided by 1/2, which is going to be 14. And then we have 1 divided by a half, which is going to be 2. And then we have 13 divided by 5/2, so that's going to be 26/5. Well, that one's going to be the smallest, and so that is going to be our pivot point. So we're going to enter here, and we're going to exit here. And what are we going to do? Well, I'm going to take 2 times row 2. That's going to be my new row 2. If I take minus row 2 plus row 1, that can be my new row 1. If I take a minus 5 times row 2 plus row 3, that could be my new row 3. And if I take 3 times row 2 plus row 4, that could be my new row 4. All right. So that's going to be where I go. So I'm going to have here, looks like a y2, then y1. So I have, write this out here wherever my pen is. I'll have a y2, I'll have a y1, I'll have an x3, then I'll have a p, and then I have a y1, y2, x1, x2, x3, p, and that. And so when I do that, I have have minus that row plus that row, so that's gonna give me 0, 1, 1, minus 1, 0, 0, and then 6. And then 2 times that row, so that's gonna be 1, 0, minus 1, 2, 0, 0, 2. And then I'll have a minus 5 times that row plus that row. So it'll be a 0, a 0, a 2, a minus 5, a 1, a 0, and 8. And then I'm going to have 3 times that row plus that row. So that's going to be a 0, a 0, a 3, a 3, a 0, a 1, and 66, I think. All right, look at that. All positive. So we're going to stop at that point, and we're just going to say the min C is equal to what? 66. And what do we have? We have x1 is 3, x2 is equal to 3, and x3 equals 0. Okay, so that's what we get. And so that's going to be our case. And if we looked over here, we're going to let that equal 0, that equals 0, and that equals 0. And so saying that those are equal to 0, that also gives me this one being 0. So that kind of double shows you that, yep, you've got the right answers there in the bottom row. And so that would be our solution to this one. All right, so let's stop with that one and we'll come back for some more.